Hello, this is a mechanics question. It's from June 2022 from AQA. You have two particles P and Q are initially at rest, so that means that maybe we need to use SUBAT at the same point on a horizontal plane. A force 40 newtons is applied to P, a force of 850 newtons is applied to Q. So we have two particles in the same point, and then we apply two different forces. One for 0, so to P, I'm going to write force applied to P is for 0, and then a force applied to Q, and I'm going to call it FQ, 815. Calculate to the nearest degree the acute angle between the two forces. So we need to find this angle here. Yeah? We know force 0 is horizontal. So to find this angle, we can use perfectly the components of this one, because we know the horizontal component is 8, so this is 8, and the vertical component is 15. So we have a right angle triangle here. So a right angle triangle with the components of Q. I hope you can see that, but this is 8 and this is 15. Which means tan of the angle is going to be opposite divided by adjacent. So alpha is tan minus 1 of 15 over 8, which is, just a second, tan minus 1, 15 over 8, 61.927 degrees. It says to the nearest degree. So alpha is 61.927 degrees. To the nearest degree is 62 degrees. Yeah, and that's the first part. Then for B says the particles begin to move under the action of their respective forces. So this particle P is moving this way, this particle Q is moving that way. P and Q have the same mass. P has an acceleration of magnitude 5 meters per second squared. Find the magnitude of the acceleration of Q. So if we have the force, right? We know force is mass acceleration, and we need the magnitude of the acceleration for Q. So we have this force for Q. We need to find the acceleration. To find the acceleration, we need the mass, and we can use P to find the mass because they give us the acceleration of P. Yeah. So for P, if we apply the equation to P, we have that Fp is the mass, which is the same for both of them, acceleration of P. So force P, I'm going to find the magnitude, yeah? So the magnitude of, for P is 4 in this case, because it's the square root of 4 squared plus 0. So magnitude of this one is 4. Is the mass, and the acceleration they say is 5. Therefore, the mass is 4/5 or 0.8. If we apply the same to Q, we have that the force at Q is going to be the mass that we just found times the acceleration at Q. Force at Q, the magnitude is going to be square root of 8 squared plus 15 squared. Yeah. So we are going to find the magnitude. I can find it here. So the magnitude of FQ to substitute in the equation is square root of 8 squared plus 15 squared, which is 17. So I'm going to write that 17 is the mass, 0.8, times the acceleration of Q. So the acceleration of Q is 17 divided by 0.8, which is 21.25 meters per second squared. Yeah? And that's all with this question.